Okay, welcome to another 2014 AQA comp1 programming exam solution tutorial looking at the card predict program. We're going to have another look at a shuffle solution. So we've looked at the riffle shuffle and now we're going to look at a Durston shuffle, a Fisher Yates shuffle. And I've talked about it a little bit when I set out the task, and I gave you the basic algorithm. And the basic gist is that rather than simply doing 1,000 swaps, where there's a real chance that there's some cards that wouldn't be moved, all we're going to do is loop through the entire deck, and perform one swap for each position with another random position. There are dozens of little variations to this. So rather than this being a swap with any position, with any random position, this random position could be generated not from 52 but from whatever's left. So it would be generated from one of the 52 positions initially, then 51. Then so basically there's variations. I'm going to cut straight to the code. No, I'm not. I'm going to just quickly make sure that you're happy with what's going on, so that this will be the first element that I swap, and then I pick a random position from here, bing, 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 that one, and they would swap. Then I would get this one, and I'd pick a random position from anywhere, ding, 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 ding. So it could be itself, it could be this one again, who cares? And let's go for that one, and they would swap. Oh. Then maybe this one, they would swap. And here, ding, 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 maybe this would swap. And it's basically working exactly the same way as the exam board's current system, but rather than just performing 1,000 random swaps, as I say, it just loops through the code once, through the deck once. So this is the code for it, so you can have a little look and copy it down. Obviously we pass the deck. We need to create a temporary, and because we're going to take both elements of the structure of the deck in one go, I'm going to create the temporary as a T card. That way I don't have to deal with the two fields separately. I need to be able to generate a random position, so I've got a nice little most recent holder for that. And then I've got my little for loop, which is going to go backwards. And actually for this particular version of it, I don't need to go backwards, but if I was to do a different version, I would need to go backwards. I'm then going to create my random position. This isn't my personal way of creating random numbers, but it is the one that's used in the other shuffling algorithm, so I thought I'd use it again. Just using the rounding and the random number, and because I'm rounding down, I'm basically truncating. I've got to add 1 to it to make sure it's going to go from 1 to 52. So that generates the random number from 1 to 52. And then I do a classic swap. Whack the random position into the temp, put the current deck position to the random, and then put the temp into the current position. So that's a classic swap. I think there's a really good chance this could come up. I'll definitely play around with it. I definitely think how you would test it, because that's quite interesting. Certainly testing any of the shuffling algorithms without a display deck procedure, and without writing to a file, the deck state to a file, I think it's quite interesting. So certainly the next solution that I'm going to do is writing a deck state to a file, but I would definitely have a go at this type of shuffle, because there's a real chance it could come up. I mean, it's quite simple, but very effective. Hope you have found that useful, and there'll be more solutions coming very soon.